Hey guys, TJ Schwarz here. So I'm really going to do it this time. I'm going to actually try to make some YouTube vlog content. So basically, I'm using my cell phone to record this, so please excuse the possible not great audio quality. Maybe it's going to be a little shaky and whatnot. I'm kind of shopping cameras right now. If you guys have any input on like what's the best camera for vlogging and this kind of work, definitely let me know. I'm kind of looking at the DJI Osmo 2, the Osmo Pocket 2. Definitely let me know what you think if you have some experience with that. But for today's content, what I want to dive into is one of the products I've been making for a lot of years is actually a comb. I've been known for doing knife work and designing knives for a long time, but a big part of my business has actually been making and selling these combs. So let me show you. So being a longtime World War II history buff, I always thought, it'd be kind of cool to do a themed project where I'm kind of designing from the mentality of a World War II era product designer. That's the inspiration behind this comb and how I started the project. It's actually been a few years since I first designed it. I've been very fortunate. I've actually made a lot of these and been able to sell them to retailers mostly and some direct sales. So the reason for this vlog content right now is I want to improve this thing. So to begin with, it's basically a folded leather handle, kind of like a sheath that's integrated. It's a grommet that holds it together, and it's just a folding comb. So this one's stainless steel. I do a brass version. So that brings us to some of these combs that I've got sitting here. There's the brass, there's the stainless. These haven't been finished at all. These are fresh out of a laser, so these are laser cut here in Boise. Here's some others that are kind of like in process. You can see some of the finishes that I actually put on those, whether it's tumbled for the stainless or a satin finish for the brass, which is what I usually do. But the main point of improvement that I've made over the years so far is, if you look, I actually have a tiny little chamfer where the comb breaks over from the tooth pocket up onto the flat there. That's kind of a cool thing that I started doing that I think makes a big difference, particularly in curly hair if you're using it. And the way I actually do that, and this is something I've never really showed off, it's something that I wasn't sure if it was the right way to do it or if I would really like it. And now that I've kind of proven it out, I'd like to kind of do a little demo of how this works. So that brings us to this huge press. So this is a 50-ton press. Actually, it's the biggest one I've had ever, and it's kind of new. So most of these combs that I've made, I was using a lot smaller press. It's actually a 20-ton. It really wasn't cutting it, so I had to do these new upgrades that I'm looking at doing. I had to go to a bigger setup here. So essentially, I've got two hardened pieces of steel here. If you look at this guy's got kind of like a reverse machine pattern of like what the shape of the comb would be inverted. And the holes drilled, kind of got to ignore those. Those were added kind of in the cam side to make sure that the tool wasn't going to break as soon as it started to enter and try to machine that. The reason being, this is actually was machined with a chamfer tool, obviously before the steel was hard, and then it was hardened. And so you can kind of see those are V notches. Now the thing about those is those chamfer tools, they don't actually machine very well laterally. The tip is really not supposed to have a load on it, and that's why we drilled that hole there. I had another machine shop help me with these, so I wasn't the one that actually made this part. Then it was heat treated, and then you can put a comb on there. Let me actually grab one of those and demo. So brass obviously works really well. One of the first steps is I have to clean up. You can see there's kind of a toothy finish on the backside from the laser. Not too bad, but I just like to clean it up usually before I put it on this tool. But basically, this thing engages right here. And you can see it's kind of sitting proud. It's not really sunk down in there, obviously, because you have a square tooth cross section trying to drop into a V-shaped valley. So essentially, the way I've been doing it is I'll essentially take this nice machine surface hardened block, put it on top of a comb like that. Then I'll use the hydraulic press, whether I use it's got an air assist, so I can actually bring the hydraulic pressure up by hooking up an air hose, or I can pump it. Just depends on how many I'm doing and whatnot. But basically, I would come down. This is slow. It's just like a jack under a car is really all it is, kind of attached to this big steel structure here. And put a bunch of pressure. Usually it's like maybe 7 tons on the brass to get this to work the way I have it set up. And then with stainless, it's pretty high. It's usually probably pushing 15, 17 tons. Stainless is kind of hard to move around like this. I believe the technical like definition for this process is actually, I want to say cold forging, because you really like it's as if you're forging a billet of material, but it's obviously doesn't have heat. And so yeah, this is what I've been working on. And the only problem I have with this setup is that little chamfer. I was super conservative when I designed this tool, and this is the first one I ever made. And I really wasn't sure, especially with the stainless, I wasn't sure like what kind of tonnage was going to be required. I wasn't sure how functional this plan really would be. So this inverted pattern was designed to only barely contact the surface and only barely do a chamfer. So if you look at like one of these combs, you can see how it's a decently large chamfer up at the top, which is where it really matters. And then on the teeth themselves, it's hard to see after it's been tumbled, but there's just a tiny little micro chamfer. Really all it's doing is breaking the edge. And I think it was kind of a quantum leap in kind of like the quality and just the way it works pulling through your hair. That little tiny edge break helped a lot. But now that I have this bigger press, and kind of the main reason for buying it is with the extra tonnage, I think I can get more aggressive with the rounding of the teeth. And so I'm going to take you through trying to make, I now have the CNC machine over there, which I didn't have when I was first developing this. But long story short, I want to make an improved version. I want to use the CNC to do it. I want to bring you along. Then we're going to try it out on this. It's going to take a little while because after I do it, I have to get it heat treated. I don't have an oven in house at the moment. But yeah, I thought you guys might find this kind of cool, and I want to take you along for the ride. Alright guys, so here is the new design. I'm in Fusion 360 right now. Some of you might know I'm definitely a SolidWorks guru, but because of the integrated CAM, which is computer-aided machining that's in Fusion, I've jumped over to Fusion, and honestly, I kind of don't see myself going back. I'm really liking this program. So anyway, I've got the part designed here, and I've got it an inch thick, which is obviously way thicker than what you saw out there, and I want this thing not to bow or bend at all. Another reason it's shorter is because basically the comb on the other one had different teeth for each side and each operation. This time it's going to share these same teeth for both sides when I go to flip it. Now some of you might have said, well, you could have teeth top and bottom and compress it and do it at the same time. I do think that's a feasible opportunity in the future, but the only problem with that is alignment and whatnot. I think is something that I'm not wanting to tackle when I'm trying to develop all of these other small little pieces. So once this is right, maybe I will do it that way. But anyway, I'm actually doing the programming right now in order to actually machine it. So I'll walk you through real quick on what I plan to do. So firstly, an adaptive clear. So in other words, a 3/16 4-flute flat end mill is going to drop in, and it's going to basically it's going to execute this program in a very calculated way to keep the tool load a very specific amount. So the program intelligently knows how much to load the tool based on what I put in. So firstly, it does a small step over to machine it all. Then it's going to do a larger step over that just clears the bottom and puts a nice finish on it. Then I have to put a nice finish on this back wall. Then a nice finish around these bosses. Then I'm going to bore out the hole, do a finish on the hole. I'm going to face off the tops of those teeth because they're lower than the top of the stock and do a finish. I'm going to chamfer some of these top surfaces just to essentially make this thing less sharp around the edges. And then I'm going to start the grooving process. So before I start the grooving, you can kind of picture if the model is not visible and I go to this step, this is what the part is going to look like going into the grooving process. I've got a boss, just a solid piece of material that only has these little kind of dimples to it at where that 3/16 end mill came along the edge. And as the grooving starts, it's going to start very shallow. So you can actually see it's very shallow. It's only a couple thou deep to start to divot in there. Then it's going to step down 5 thou at a time, do it again and again and again. And once it's at full depth, you can kind of see right there. One of the main things that I had to address is, as you can see, this channel is wider than the ball end mill is. So at the very center here, after all this machining, there would be a little ridge. And then also right up here, where it's never really machined, there would also be like a little nipple almost. And so what I've done is I do one more pass where it's narrower and try to alleviate maybe that center ridge. And then also I'm going to close in with these little V-shaped machining patterns to basically try to machine away the leftovers of whatever might be right there. Then I cut across with a straight line with that ball end mill to try to really clean up that back edge. And theoretically, that could be it. I think I have my feeds and speeds realistic on this, and tool steel's in a non-hard state is actually not too hard to machine. So I'm kind of looking forward to it. I'm gonna give it a try. So right here are my pieces of bar stock. 1 inch by 1.5 inch precision ground. This is 01 tool steel annealed. So it's nice and soft. I'll be able to machine it and then I'll have it hardened. Now I had this bandsaw cut. You can see on the end that's bandsaw cut. Bandsaws never cut straight at all. And then this was the factory end cut. I'd like for this thing to be machined on the ends to be nice and square and straight, even though it really doesn't matter for this part. I just like it to look nice when it's finished. So I'm going to go ahead and throw it in the vise, and I'm going to work on machining the ends of this nice and true. One small complication with machining the ends of these nice and square is my longest end mill is, I believe, a flute length of 0.625, which is, what is that, 5/8. And so with this being 1 inch thick, if I'm going to cut with the side of any machining tool to machine this square, I'm going to have to come at it from both sides. I'm going to have to flip it 180 degrees, which isn't ideal. It just means that I'm going to have to probe it or, I don't know, probably probe it. That's probably how I'll do it. But I could turn it on end and machine the end, but with the other side not being true, there's no way that setting it on end is going to be square, at least on the first side. So once again, this doesn't really matter. These ends aren't critical to the actual function of this part. I'm just going to machine it, flip it, and probe it, machine it again. But yeah, should work. Alright, some of you guys aren't going to believe me. I just got out here to the machine. I put the USB stick in, got the code going, getting it ready to go ahead and machine this piece of billet here. Tell me what you see when you look at it on this screen. I'm a Jeep guy. That was an accident. Come on, tell me you don't see that. So I've got her all machined on the ends to be just the right length. Sitting in there exactly the way I want it. Got the vise clamped down. We're ready to machine it. Let's see how this goes. Just got to probe this puppy in and we're good to go. So we're going to start this. We're going to see how she goes. This first tool, I'm a little worried, is kind of dull. I'm not sure how sharp it is. Let's see how it goes. Yeah, honestly sounds really good. Sounds like a pretty good tool load. I think my feeds and speeds chart were good to me on this one. So we're off to a pretty good start. I'm really happy with how that 3/16 end mill kind of machined that out. Man, that ran smooth. It's a nice finish. I mean, it looks a little bit kind of knurled just visually with kind of a reflection going on, but it feels really smooth. I'm actually kind of impressed. That worked good. The only thing is, when I went to plunge in to do those holes, it was too aggressive. Just the overall programming wasn't good, and I broke the tool. So you can see right here. See if I can show you. That's supposed to be square on the end, so I buggered it up a little bit. It's not going to be a big deal. I may never even use these holes. I'm going to have to adjust the program and come back in, and I'm going to pre-drill. I'm going to do a little bit less aggressive on the helix going in. That being said, I wanted to check the size of the diameter here. Really stoked about that. Looks like it's gonna work good. Gonna be able to fit them in there. Just about perfect, man, that worked good. So I'm gonna deck off this right here, and then I'm gonna change the programming and come back and try to finish it up. So, big bummer, just made a major mistake. I ran a chamfer and I ran it too deep. Must have been a tool offset issue or something. I've got a pretty huge chamfer right on this boss and on this back wall. I'm not liking that. When the comb is supposed to be sitting on there, before the press comes down and puts any pressure on it, it's not going to be engaged and thus aligned and centered, especially with the way that back wall is chamfered. I kind of planned ahead for the possibility of having to improve this design, and so all I'm going to do is I'm going to just lower this whole program down by, I don't know, 20 thou or something, and rerun it with a different chamfer, so this whole thing is just going to get machined a little bit lower. I don't really see any other option. That's what I'm going to do. So I decided before rerunning the part, I want to try those grooves out. This is the hard part. This is the smallest tool. This is the part where I'm most likely to break a tool. I thought, well, before I restart this whole operation, I might as well test run that and just see how well it goes. So far, so good. Alright guys, moment of truth on these grooves. Looks pretty good. Looks really good from here. I'm gonna have to get a closer look. So the only thing I'm noticing, guys, I don't know if you're gonna be able to see this, but this side's pretty clean transition. This side, there's that kind of a crusty looking burr. Now, I was picking away at it and it just flakes off. I'm gonna have to keep looking at it and see how I feel about that. I don't know if I need to make some adjustments, but like I said, as it transitions to this side, that kind of goes away. Well, I know I'm gonna have to do a little bit of hand fitment and sanding maybe on that little edge where it fades in. Might be okay. So guys, I do think this is gonna work. I remember on the last one that I made years ago, I did have to kind of sand right in that transition. Where the tip of a ball end mill is cutting is never going to be a perfect finish. You can research machining and see why that is, but essentially doing pretty good on this. I think it's going to work. Like I said, I still have to bring this whole thing down like 30 thou maybe to clear up that chamfer issue. I think I'm probably not even going to chamfer it this time and risk it. On that other one that I've been using, there is no chamfer. I don't think it's all that necessary. So I'm going to deck this whole thing off with a big old 1/2 inch end mill, bring it down. I might even go like 50 thou and then remachine this whole program with the chamfer deleted and with a little bit different approach to making that hole. So I just had a realization. This is awesome, guys. Because I messed it up once and I was going to remachine it, it occurred to me, why don't I test it right now? It's not hard, but it's probably a little bit harder than brass. I'm going to test it on one of those combs, just see how it looks. It's probably going to damage this irreparably. It's only probably a little bit harder than the brass is, but as a test, it'll probably prove out maybe flaws with the design before I go and heat treat it and then find out. Alright guys, here we go. I'm not expecting great results with non-hardened steel, but we shall see. So 2.5 tons, 5 tons, we're up to 10 tons now. I'm gonna go ahead and release it and just see what happens. Lift the ram up a little bit. Here we go. I'm also expecting this thing to be stuck in here because the soft materials are probably kind of bond. Let me get something to chip that out of there. So as you can see, 10 tons didn't do a whole lot. Not sure what's gonna happen if I really up the tonnage, but I'm gonna give her a rip and just see if it really starts to round that out. So I upped the tonnage. I'm pretty damn happy with that. You can see the rounding that's going on all the teeth, and especially up top where it really counts. There's artifacts from that debris that I had pointed out that's showing up. Now, I'm happy with this, but the main issue I'm seeing, looking between the teeth, you can see how it's almost like those little raised plateaus on the actual plate, on that machine plate, is kind of snagging on parts of the brass. and almost forcing it downward into the teeth. I don't want that. Obviously, you can't have those sharp edges inside there. I think I have a solution. So I'm actually remachining it. I decked the top down, and then I'm just gonna remachine mostly the same. Once it's done here, I'll show you the little tweak I made. So my supposed cure for the way the edges of these were kind of catching that brass and kind of peeling it back down into the teeth is I think they need just the tiniest chamfer around the top of that plateau so that the brass wants to kind of fall inside rather than get hooked on it and kind of drag out. So what I'm actually doing is I programmed for this chamfer tool right here, focus, to basically make a pass in through each of those little channels. And because chamfer tools are a little hard to use that precisely, I'm slowly walking it down. At this point, I've made contact. Now I'm going down literally 1/1000th of an inch at a time, and I'm checking it every time and trying to get this to be exactly what I'm looking for. So I hope you guys can see it. Ignore the really bad kind of burrs hanging out the bottom of those channels. Those will get cleaned up later. You can see the little chamfer around the top of each of those bosses. That's what I'm looking for. I think I'm going to stop right there. That'll kind of channel those teeth down in there and stop it from catching, I think. So just to clean up that very front edge, I'm actually manually jogging this and chamfering it. Stop the spindle. So that's much cleaner. Alright guys, I might have to pull this thing out and get a close look at it. Alright guys, here's the finished part. Can't get too good of a macro shot from a cell phone, but you can see kind of how those are designed with the radius leading out of the bottom and a little chamfer on top. Got the holes right this time. Feeling pretty good. I think she's ready for heat treat. Alright guys, so in order to have that heat treated, I have to call in a friend of mine to help me out. He's got a heat treat oven, he lives nearby. I'm going to have him do that for me. I'm really excited to test that on the stainless steel. That's going to really require a lot of tonnage, and I'm definitely going to be posting a video. You can also keep track of what I'm doing on Instagram at knife.designer. This is it for this video. I really hope you enjoyed. Please comment if you want me to kind of keep this going. This is all experimental for me. I haven't done a YouTube channel like this before. I really did have a lot of fun with this video. I want to do it again. Hope you're along for the ride. Thanks guys.